Hi, this is Jeff Spence, your Math for Liberal Arts instructor at the Community College of Denver, and this is a third lecture over percent applications. Just to point out that this is a continuation, a little bit of my percent applications part one video, where in this video you can see that I was using Formula 2 here, applying a given percent. You can see the example of what is 7.3% of 500 and the next two examples here. But the examples that I'm going to do here are a little bit different and a little bit more complicated because they're similar to this example here, where the Damian Lillard example that you saw in that first video, where I'm going to take a percent of an unknown amount and I know the result. So I'm going to have to do a little algebra to solve. But the difference between that problem and these problems is that the percent given and the result that we know, the percent given is an increase or a decrease, which makes it a little bit more complicated. So let's take a look at these two examples. Either way, I just want to point out before I start both of them is that in both problems, we're given a percent. So that means that we're going to be using Formula 2. We're given a percent. So we're going to convert that percent into decimal form. And then we're going to decide if we're given the result of the amount or the total or the portion to figure this out. Now I also wrote in another form of this formula that's makes a little bit more sense for these types of problems. Instead of total and portion, sometimes we take percents of amounts and get results. Same thing, just different terminology. Okay, so let's take a look at this first example. It says you found you got a 15%, or you found out, or you were told that you got a 15% raise at work, and now you make 17.15 per hour, 17.50 per hour. So what's happening here is you're getting a percent raise, and now we know the result of that percent raise. So the 17.50 is going to go over here. We want to figure out the amount that we made before the raise. But what makes this problem a little bit trickier than, say, the Damian Lillard example is that it's a 15% raise. So it's not 15% of your previous pay is the 1750. It's the 15% increase that you're getting. So you're already making 100% of what you make, plus you're getting 15%. So this actual 15% raise means that you're getting 115% of your original pay. And that will turn out to be the result of $17.50 per hour. The thing is we don't know the original pay, and that's what we're trying to figure out. But when we do percent of a number, what we do here is we convert the percent into decimal form. So that's going to be 115%, which represents a 15% raise, 115% of your original pay, so 1.15, take that number, divide by 100, or move the decimal 2 spots to the left, of the original pay, which I don't know, so I'll just call that X, gives me the 17.50 rate that I make now. So remember, this is a 15% increase, so I represent that by 1.15 of the original amount gives me the result of 17.50. So the hard part is just making sure that you understand that that 15% raise is not just 0.15 of the original pay, it's 1.15 because you're getting the original pay and adding on 15%. From here, once we have the setup, it's pretty easy. You just take 1750 and you divide by 1.15. You get your result. I'll show that here. And we round to the nearest cent because this is a money example. So that's the nearest hundredth. So it's going to be $15.22. That 7 rounds that one up to 22 cents. So $15.22 per hour. That's the first result there. We cannot do this problem by taking, let me show you on the calculator, you cannot take 15% of 1750, which is 263, Let me just jot that down somewhere, 263, and then subtract that off. That's not how this works. Excuse me, open the calendar. Because the 15% is not being taken of your new pay, it's being taken of the original pay. So if I do 1750 minus 263, okay, and let's say, all right, well, I think I made 1487. If I do that times 1.15, which would represent the 15% raise, guess what? It's not 1750. So when we do these backwards problems, when we're finding an amount in the past, you have to do it this way, where we're solving for the unknown amount by dividing. Okay, let's take a look at another one. This is a really similar example, and then I'll do a third example. An item costs $56.34 including tax. If the tax rate is 7.6%, what was the cost of the item before tax? So notice in both of these, we're trying to figure out a previous amount after a percent was already applied. So the percent was applied and we get the result. We need to go back and figure out the previous amount. But what's different about both of these examples compared to the first video is that the percents are added or subtracted on. 15% raise is 15% more than what you already made. That's why we had the 115% or 1.15. Tax rate is the same thing. Tax is a percent that's added on to the 100% cost that you already pay. So that tax rate of 100%, remember, when you buy an item at any store, you're going to pay 100% of the price on the price tag or whatever the price is listed, say at the grocery store, and then you're going to pay another percent on, in this case 7.6% added on. Tax is added on as a percent of the price. So ultimately you will pay 107.6% of the original price. And that gives you the price including tax of $56.34. So it's very similar to the last one. Tax is added on. So to set this up as an equation, we convert the percent to a decimal, move the decimal 1 spot or 2 spots to the left, or divide it by 100, 1.076 times the original price. Anytime we do a percent of something, we multiply by that thing, or convert the percent to a decimal and multiply by that thing. We don't know what the original price is, so we call it X, and that gives us $56.34, the price including tax. That's the result. Once again, we do the same process. We divide 56.34 by the 1.076, and then we're going to round this to the nearest cent because it is a money example. So 56.34 divided by 1.076, round to the nearest cent, 52.36, price before tax. Okay, let me write the third example here. Okay, and here's our last example here. We have an item cost $67.40 after a 20% off sale. What was the price of the item before the sale? So all these problems have this similar theme where there's a percent increase or decrease, and we want to find and we know the result, but we need to find the price or the value before this percent increase or decrease. That's the theme. We want to find the amount after a percent increase. We want to find the amount of an item, and we're given the result after a percent increase or decrease. So we want to figure out the previous amount. We're always given the amount after that percent increase or decrease. But what's different about C compared to B and A is that when we have a 20% off sale, that's actually a 20% reduction. So instead of paying 100% of the item, you're going to pay, when you take the 20% off, you're going to pay 80% of the original price. 20% off is the same thing as 100 minus 20, 80% of the original price. And we know that the result price is $67.40. So once again, this is set up algebraically as we convert the 80%, so 0.80 times the original price, 80% of something we don't know, so 0.80 times x gives me the 6740, and then it's the same process. Divide by 0.80, so x is 6740 divided by 0.80. Round this to the nearest cent, so let's take a look at what that's going to be. $84.25, no rounding needed. And those are three examples of where we have the result, the right number, after a percent increase or decrease. This is similar to the Damian Lillard example, but in these problems, there's a percent increase or decrease. So I had to do the 100 plus the percent increase in both examples A and B, and 100 minus the percent decrease in example C. Then I do that percent times the unknown amount, gives us the result, which is given, divide to find the original amount. That's it. We'll see you next time.